All right, we want to start off going over, I've got about 8 or 9 problems that many of you missed some form or fashion of that I want to go through here, and then we'll work any and every other problem that you might want on the test. So I encourage you to go through and make notes on your test of what you did wrong and correct it. Not because you're going to see that problem again, but because you're going to see something that needs those skill sets again. Some of it is going to be issues where you're going to say, oh, I should have known that, okay? So the first one I want to look at is problem number 5. And we'll be glad to come back and look at any others that you might have as well, okay? Problem number 5 says, if f of x is tan 2x, then f prime at pi over 6. First thing you got to do is take the derivative, and that's where many of you messed up. If you got minus 4 on number 5, it's because you didn't take the derivative right. What's the derivative of tan? Secant squared, okay? So a secant squared of the same argument, you also have to use a chain rule in here, times the number 2. So that's what you should have for the derivative. And then we're simply asked to evaluate it at pi over 6. Well, what does that look like? Pi over 6. It becomes a little bit of an algebra game here to figure out what this means. 2 times pi over 6 is pi over 3. So we're actually trying to find out what's the secant squared of pi over 3. We don't remember secant, but we do remember that it's 1 over the cosine squared of pi over 3 times 2. Well, so now, what's the cosine of pi over 3? That's the big question, okay? I don't know how you remember this, okay? I remember it as this is my 0 angle, this is pi over 3, this is pi over 6, pi over 4, pi over 3, pi over 2. So I'm looking for this angle right here, okay? I remember that the cosine starts off at 1 and it walks its way down. So if it's 1 here, it's the square root of 3 over 2 there. It's the square root of 2 over 2 there. It's the square root of 1 over 2 there. It's the square root of 0 over 2 there, or just plain old 0. That's what I remember. I don't know if that's what you remember or not, but that's the way I remember this. This is part of my unit circle that I'm looking at here, okay? So pi over 3 is that one, which is 1/2. So that tells me then I've got 1 over 1/2 squared times 2. Well, a half squared is a quarter, so I've got 1 over a fourth times 2. That becomes 4 times 2, becomes the number 8. So 8 was the correct answer for 5. Most of us that missed that didn't take the derivative right. I saw tan of 2x for the derivative. I saw tan of 2x2 for the derivative. I saw sec x tan x for the derivative. But then some of you didn't get down here into this stuff correctly. You didn't remember what the cosine of that is. That's not something we have time to teach. We just got to know those things. Any questions about number 5 here now? Okay, let's move forward. Let's look at number 7. Number 7. Problems here. Most of the problems here, I think, were chain rule taking the derivative, because we're taking the derivative of sine, so we know that it's cosine of the same thing, times the derivative of e to the negative x. What's the derivative of e to any power? E to any power, the derivative is e to that same power times the derivative of that power. The derivative of negative x is negative 1. So we've got a cosine e to the negative x. That means it could be any of them. We have it times an e to the negative x. That rules out b and c because I don't have pluses and minuses in there. And it rules out a, so I'm down to d or e. The fact that I've got this negative makes it e is my answer here. I think most of us that missed that, probably it was taking the derivative. Some of us left off this minus sign. Probably quite a few of us put d there for it. Okay? Questions about 7 there? 8. 8 is one that I really expected a lot of you to really fuss and argue over quite a bit. But some of you did much better on this than I expected you to. Some of you missed the algebra at the end. That's the reason you got only 1 or 2 points off. But it gives us a function for f. It gives us a function of g. Then the derivative of f of g of x at x equals 3. Lots of confusing things to do there. But if you remember, this terminology here means that we're putting g in place of x over here. So my function that I'm really trying to find the derivative of is 3x minus 2 squared minus 4, the square root of all that. So I've just got to find the derivative of that. Well, I'm going to start off by saying I can rewrite that to the 1/2 power. Now, I can't remember, this is my function. Somebody, I think, has got a real big no written on their paper right along in there because they went through and said, well, that's just 3x minus 2 minus 4. Just distributed this 1/2 through there. Why can't I distribute the 1/2 power through that parentheses? Why can't I just take the square root of 3x minus 2 squared and the square root of 4 and say, subtract them, boom, I get 3x minus 2 minus 2, I get 3x, so the derivative is 3. I can't take a square root until I've done what's on the inside here. That subtraction sign says I can't just distribute it through there. So some of us did that. A couple of us did this. They said, oh, well, I'll just distribute this squared through there and make it 9x squared minus 4. Can't do that either. Why not? Same rule, same thing. If I square this thing out, back in Algebra 1, if I square a binomial, I'm going to get a trinomial. I'm going to get 3 terms. Front, back, I've got to FOIL it. So I've got to take the derivative using the chain rule. So the chain rule says 1/2. This same stuff, most of you did well with that, to the negative 1/2. Somebody left that power off and messed up everything. Times the derivative of the inside. Well, what do I do when I'm taking the derivative of this? I know that 4 is going to go away. I got to use a chain rule again for that 3x minus 2 quantity squared. So it's 2 times 3x minus 2 to the first power times the derivative of this 3x, which is just plain old 3. So that's my overall derivative. Now, you could clean it up, but look at what we're trying to do. We're trying to figure out what's the derivative at 3. So I would just plug in a 3 right now and see what you mad at yourself now because you were there but you weren't there? Okay, so when you go through this, what happens when I put 3 in here? 3 times 3 minus 2 is 9 minus 2. That's going to be 7. So I've got 1/2, 7 minus 4 to the negative 1/2 times 2 times 7 times 3. Did I do that right so far? Oh, no, I didn't do that right, did I? Right here I messed up. It's 7 squared minus 4 to the negative 1/2. Well, I don't like that negative 1/2 power, so what can I do? Come on, what can I do with that to make that negative 1/2 power possible? Put it on the bottom. So 7 squared is 49 minus 4 is 45. So I'm going to put a square root of 45 on the bottom. This 1/2 and this 2 will cancel out. So they'll go away. So I get 21 root 45. Look back over here at my answers. I don't have that anywhere. Several of you got to that point and then guessed at something. Okay? What can I do now? This is way back in Algebra 1. Anybody remember? What can I do with that square root of 45 now? Anybody remember? Now I can branch it out. Yep. You either remember it's 9 times 5, and that makes it 3 root 5 with a 21 up top. And bummer, that 3 will go into the 21 7 times, so I get 7 root 5 for a final answer. Lo and behold, it's up there. So now I think if you took the derivative right and got to here and messed up, I think I gave you one. I only counted on 1 or 2 points off there, I think. So just somebody went from the Somebody had square root of 5 here and wrote square root of 21 over here. I don't remember who that was. Somebody did that. So some careless mistakes in there. But do we understand how to get there now? Some algebra mess up is probably what we did there. Again, if it was -4, it's because you took the derivative wrong up here. Okay. Number 9. Okay. Number 9 always trips up students. Every time. And when I show you what it is, you say, oh, I should have known that. Okay? A particle moves along the x-axis with its position given by that. For which of the following values is a particle at rest? What does it mean to be at rest? Not moving. Rest is not moving. How is something not moving? Am I moving now? What's 0? Velocity is 0. Not position. I can be anywhere on the earth and not be moving. But the velocity is not equal to 0. So I have to take the derivative of that. That's my velocity. How do I take the derivative with no numbers in it? What did we say? A and B are constant. So A and B we treat like numbers. So we've got first times the derivative of t minus b. Remember, b is a constant, so its derivative is 0 times 1 plus the second, which is t minus b, times the derivative of the first. Again, a is a constant, so it's just that. So my velocity is t minus a plus t minus b, or b, not a, which is 2ta, come on, Ely, right, 2t minus a minus b. Now, we said we wanted it to be not moving, so the velocity is what? Equal to what? 0. 2t minus b equals 0. 2t minus a minus b equals 0. Well, all of our answers are t equals. Let's see how we can do that. 2t equals a plus b, if I add a to both sides and add b to both sides. So then t equals a plus b over 2, which is answer B. Now, some of you got that. I was very proud of those of you that got there, okay? It's not uncommon for folks to mess up on that problem. That's one when I put it on the test, I said, yep, that's going to create some difficulties for some people there. It's all right. It's a learning experience. Questions? Got to be careful of the words there, okay? Careful of the words. All right? This one. Now, notice what we're given to start with. This is number 11. And we'll come back and look at any others y'all might need to. Okay? So what's dy over dx? That's my derivative. But it doesn't say the derivative is 2x minus y. It gives us an expression. So our first thing we've got to do is figure out what is dx minus dy. It's 2x minus y over x plus 2y. That's the dy over dx. Well, what does this ask for? I told you, what is that asking for? Second derivative. How do I take the derivative of this? Quotient rule. Several people said, no, I'll just take the derivative of the top, derivative of the bottom. That'll be a lot easier. It is. It's wrong, but it is easier. So we've got to take the quotient rule. For the second derivative, it is low d high, which is 2 minus y prime, minus high d low, which is x plus 2 times y prime, over the denominator squared. Low d high minus high d low over the denominator squared. Now notice though, it didn't say clean it up. It said evaluate it at the point 3, 0. So there's no reason to do any algebra. Did I mess up something there?
Shouldn't the x for the d low first part be 1?
Yep, right there. Thank you, sir. 2x minus y times 1 plus 2y prime. So There's no reason to clean up anything. Just plug in what we know. 3 plus 2 times 0 times 2 minus, well, what's y prime? How can we figure out what y prime is? Well, we've got an expression for y prime up here, don't we? 2x minus y over x plus 2y. So we can say at 3 comma 0, that is 2 times 3 minus 0 over 3 plus 2 times 0. That's just the number 2. So we can, everywhere we've got y prime at, we can put a number 2. Well, look at what happens to all of this front matter up here. 2 minus 2 is 0. I'm multiplying by that, so poof, all that's going away. Minus 2 times 3 minus 0 times 1 plus 4. 2 times y prime, 2 times 2. All over 3 plus 2 times 0 squared. Now all that goes away, so I've got minus 6 times 5 over 9, which is minus 10 thirds when we reduce it down. We get minus 30 over 9, which will reduce to minus 10 over 3. Now some of you got D, 10 thirds. You messed up on a sign, S-I-G-N. Careless mistake there somewhere. I can't tell you where you made the mistake, but you probably have figured it out by now. So, but that was a process to go through. Questions, comments, observations? All right, 12, 13, and 14, I think y'all did real well on, even 15 and 16. We'll go back and look at those if we need to, okay? But I wanted to specifically look at these last 4, and then we'll come back and look at any y'all want to. Now, once you got to 15, 16, 17, and 18, calculator can be used. So use the calculator. And I want to show you on the calculator how I would approach this problem here. Okay? The graph of y equals e tan x minus 2 crosses the x-axis at one point on the interval. What is the slope of the graph at this point? Okay? Some of us got really confused with just our word stuff here. Don't get confused, okay? The graph crosses the x-axis at one point. What's the slope at this point? So we've got to do two things. We've got to figure out where does this graph cross the x-axis, first of all, and then find out the derivative at that point. With our calculator, we can do it all pretty much in the same step. So I'm going to go to my function here, and I'm going to find my E button, which is second ln, e to the tan x power minus 2. That's my function. So we want to know where it crosses the x-axis. How do we figure out where it crosses the x-axis? We go to second, calc. Crossing the x-axis is the same as a 0. So 2. Oh my goodness, it looks like it crosses a bunch of places to me. But we're only concerned about it where? Between 0 and 1. So left bound 0, right bound 1. We don't care about guessing. So that's where it crosses the x-axis. And some of you did that and wrote the answer down. It's not the question. It is the answer for a question. It's just not the question that was asked. 0.606111993. That's just using the 0 feature. But we didn't ask for what was the 0, did we? We said, what's the slope at this point? Well, if we go back and say second, calculate, number 6, dy dx, where do we want to do that at? It's 0.606. 2.959. What's the closest thing to that up here? 2.961. Is 2.961 the right answer? D was the right answer. Why am I off by a little bit there? Can anybody tell me? Because I got 2.959, which is 2.96 actually is what I would get. Why am I off a little bit? Does that bother us?
It's just like round off.
It's just rounding. Because what number did I put in there? I put .606, but it wasn't actually .606. It was .606111136. That's how I would have done all of that with my calculator. You say, I don't know how to do all that with my calculator. Then we want to know where this crosses the x-axis. So E tan x minus 2 equals 0. Well, that means E tan x equals 2, right? How do I get rid of the e's? Somebody has said this before. ln. If we ln both sides, we get ln e to the tan x equals ln of 2. We can bring the tan x down, and ln of e is just 1. So tan x equals ln of 2. Now we need to do the arctan. So on my calculator, there's no way to solve this without the calculator. On my calculator now I could say, let's clear out of here, ln of 2, and I need the tangent of the arctan for that. So second tan of that answer. There's the .60611. Again, that's where it crosses the x-axis. That's where it crosses the x-axis. We need to know the derivative at that point. We could go back. What's the derivative of y? Y prime is e to that same power times secant squared of that power. E tan x times secant squared x. And if you put the .6061193 in there with your calculator, you'll wind up with a 2.961. With a calculator, that's a doable problem, though. Lots of fun there. All okay? Some of you are just thinking, oh my goodness. Okay. 18. A particle moves along the x-axis so that at time t greater than 0, its position is given by what is the velocity of the particle at the first instant the particle is at the origin. Okay? So you got to figure out first, what am I asking for here? Velocity. Well, I got to figure out the velocity. That means I need to find the derivative of that somehow or another. It says at the first instant the particle is at the origin. What does it mean for the particle to be at the origin? That's right. X of t equals 0. So we got to figure out when is x of t equals 0, and then figure out the derivative at that point. Again, with our calculator, this is a doable problem without doing a whole lot of writing even. It's the cosine of x raised to the 0.5 power. Okay? Now, if we graph that thing, let's graph it. We said we wanted to know when it's first 0. So we want to know when it crosses 0 the first time. So we'll do second calc. Calculate the 0. Left bound is 0. Right bound, I just want to see when it becomes y is negative, so it's somewhere in there. Boom, boom. So it happened at x equals 2.467. We need to know what the velocity is at that time. Now, I have a question totally unrelated to the problem, but see if it'll help you figure out something here. This is a graph of the position of it. What can you tell me about the velocity at that point? Why is it negative? The function's going down, so the velocity has to be negative. So suddenly you know it's got to be A, B, or C if you've graphed it. It's got to be one of those. So now we need to figure out what's the derivative at this point. Well, we can do it the algebra way by taking the derivative of that, which is minus sine of the square root of t times 1/2 t to the negative 1/2. And plug this number in there. Or, with our calculating device, we do second calculate. We want to calculate the derivative at 2.467411. That's what we got over there. And we got a derivative of negative 0.318, which is C. How do we feel now? You're not unsmart people, okay? You are smart people. You may not feel like it after this test. That's okay. It's good for you to have a test every now and then when you find out that you're not the smartest person in the world. It's better to do it now than next year when you're off at college for that first test. Okay, so you're not unsmart people. You're very capable of doing this stuff, so don't get down on yourself. Very happy for the most part with 19. Okay, 6 parts here. Most of us did those well. Let's walk through those. Most of us did parts of it well. So A part says find the average velocity of the diver, okay? Average velocity. Average velocity is not calculus. Now let me show you what you had to do. You had to find S at 1.2 minus S at 1 over 1.2 minus 1. That's the average. Okay? Here's what some of us did. Some of us took the derivative and put in 1.2. That's not what we asked for. We said average velocity. Some of you took the derivative and put V of 1.2 and V of 1. Okay? If you think physics for a second, if you think velocity is meters per second and we're dividing it by second, meters per second is not velocity. So it's got to be position divided by time, and I think we get negative 19.2 if we do that math there. Okay? Now B part. B part says when does the diver hit the water? When? That tells us we're looking for a time. Okay? Now, so how do we figure out a time for when he hits the water? Well, he's starting off up here. He's starting off 32 feet above the water. So where is he when he hits the water? His position is 0. So we set S of t equal to 0. So we say negative 16t squared plus 16t plus 32 equals 0. And if we factor that thing out, t squared minus t minus 2 equals 0. T minus 2, t plus 1. We get 2 answers, t equals 2 and t equals negative 1. I throw the negative 1 away. Why? Why do I throw the negative 1 away? Because I'm only looking for one time. He didn't hit the water twice. How do I know it's at 2 seconds and not negative 1 second? Negative 1 second is before he started. So t equals 2 is the right answer for B part here. T equals 2. All right? Now, I can't remember who, somebody set the position equal to negative 32. Okay? He has moved 32 feet, but where is negative 32 in relation to where he started? Negative 32 is not at the surface of the water, it's 32 feet under the water. So we've got to go 0 is what we want to know when it's 0. So 2 seconds. C part, what's the diver's velocity at impact? All right, for C part, I need to figure out his velocity at 2. What's his velocity at 2? Well, I need to know his velocity first of all. Velocity function is negative 32t plus 16. And at 2, that's negative 64 plus 16, negative 48 feet per second. So that's how fast he's going. Going down, he's going at negative 48 feet per second. D part. During what time interval is the diver moving upward? All right. What does it mean for him to be moving upward? If he's moving upward, what's true? His position's going up. His velocity is what if he's moving up? Positive. So how do I know when he gets to the top of his jump? When he starts coming down. Before he can come down, what has to happen? The velocity has to hit 0. Remember, we talked about this. He can't be going from up to down without going through 0. It's physically impossible. So we need to figure out, when's the velocity equal to 0? Well, negative 32t plus 16 equals 0. When negative 32t equals negative 16, when t is a half a second. So what interval is he going up? From 0 to 1/2. Okay? Because he started going up at 0, and at a half second is when he reaches the max, and he's starting to come back down. Then when does the diver reach his maximum height? E part, when does he reach his maximum height? It has to be at 0.5, okay? Because what happens? He jumps up, he goes back. Does he ever loop back up and go higher? Nope, not going to happen. He's going to go up, then he's going to go down. And F says, what's his maximum height? So we need to find his position at 1/2. And if you work that out, I think you find that it's 36 feet. Okay? Challenging words there. Challenging wording in that problem there. So if you got to learn the terminology there. And then let's look at the last one. Given two functions, f and h, such that f is this function and h is this piecewise function. All right? Find the zeros of f. How do we find the zeros of f? How do we find the zeros of f? Who remembers that? Set it equal to 0 in group. That's how some of us learn to do that. Okay? Because you can factor an x squared out of the front and get x minus 3, a minus 4 out of the back and get x minus 3. Then we can factor out an x minus 3 and an x squared minus 4. So we get x equals 3 and plus or minus 2. Whoops, 2. All right, for those of us that don't remember how to factor by grouping, what do we have to do? We have to do something called synthetic division. All right, synthetic division is 1, negative 3, negative 4, 12. What possibilities do I have? What are the possible candidates that I could divide by there? How do I determine the possible candidates? They are the factors of what? Factors of the last 12 over the factors of the first one. So I've got 1, 2, 3, 4, 6, and 12. We always start off with the easier of them, 1s, 2s, and 3s. I'm going to decide to start with 3 for some reason. So 3, negative 3 is 0 is negative 4 is negative 12 is 0. Lo and behold, it works. So 3 is 1. This is x squared minus 4, which gives me plus and minus 2. So that's my zeros. B part said find P so that H is continuous. So that H is continuous. So what is it? What has to be true for H to be continuous? Three-pronged test should jump to mind. Okay? What is H of 3? Well, when we plug 3 in, H is defined to be the number P. Then we need to know the limit. What is the limit as X approaches 3? Normally we do the left and the right. Which rule do we use if we're going to 3 from the left? Top or bottom? Top. Which rule do we use if we go from the right side for that? Top or bottom? Top. So we're going to use a top one either way. So it's going to be f of x over x minus 3. Well, I'm going to write f of x like this. Now, where on earth did I pull that rabbit out of the hat, people? Why did I write it as x minus 3 over x squared minus 4? It says f of x, and f of x is this mess up here. That's right. Remember, we found the zeros in A part. That means these are factors. So that means if I multiply these two things together, I get back to F. Well, why would it be to my advantage to write it like that? Suddenly things will factor out, won't they? Those will go away. I can put in 3 and I get 5 out. Well, if the limit's 5 and the function is P, what does P need to be so it'll be continuous? P equals 5. Boom, several of us got there. And then C part, we're supposed to determine whether it's an even function, justify your answer. Okay, if you don't have any clue, at least write down yes or no, because you're going to get something for yes or no there. If it's right, you're going to get something. So, is it an even function? Yes, it is an even function. How do we justify the answer? So, let's see. So, we've got h of x. In order to justify it, we have to put negative x in. Well, if we put negative x in, we get negative x minus 3 and negative x squared minus 4 over negative x minus 3. Well, how can I clean that up? This negative x minus 3 in the numerator is the same as the one in the denominator. And I can clean that up to just be x squared minus 4. And that's the same thing as what h of x was if we simplified it down. Therefore, it's even. All right, what other questions do you have? Which other ones do you want me to work through or look over or anything? Be glad to look at any or all of them. If you want to sit down with me one-on-one and look at some, I'll be glad to do that. All right. 10. The function f is defined by what points x, y on the graph have the property that the line tangent to f has a slope of 1/2. Okay. Several places people made a mistake here. First thing, we've got to find the derivative. The derivative requires quotient rule here. Some people messed up right there. I just wrote minus 4 and kept going. Low times the derivative of the high minus high times the derivative of the low over the low squared, which becomes x plus 2 minus x over x plus 2 squared, which becomes 2 over x plus 2 quantity squared. So there's my derivative. But what do we say? What points have the property that the line tangent has a slope of 1/2? Okay? Now, you got a couple of ways to go with this, okay? First of all, it's multiple guess. What happens if I put 0, 0 in here? What happens if I find the derivative at 0 right now? I get 2 over 0 plus 2 squared, which is 2 over 4, which is 1/2. Okay, that's the that's the non-mathy way to do this. It's just, okay, so I know A has to be right. I don't have to look at B. Boom. I know that ain't right. I know that ain't right. So now I could try either 4 or negative 4. Well, what is f prime at 4? If I put 4 in there, I get 2 over 4 plus 2 squared, which is 2 over 36. That ain't 1/2, I don't think. So, boom, that one can't be it. So now what about negative 4? 2 over negative 4 plus 2 squared. I get 2 over, that looks like 4 to me. I get 1/2 again. So it looks like A and C those are the two answers. Now, if you're thinking algebra like I want you to, that's test-taking skills that got me those answers. If you're thinking algebra, I'm going to take my slope, 2 over x plus 2 squared equals 1/2, because we said the slope has to be 1/2. Okay? Notice I have squared in there, people. What does squared imply? Two answers. I've got x plus 2 quantity squared. So I'm expecting to get two answers with this. If I cross multiply this, I get x plus 2 squared equals 4. Now I can take the square root of both sides. Well, this becomes x plus 2. When I take the square root of 4, though, I get plus and minus 2. And then I get x equals plus and minus 2 minus 2. So if it's 2 plus 2, it's 0. If it's negative 2 minus 2, it's negative 4. So there I would get my answers that way. Some of us got there and just said, 2 works in it and 0 works in it and didn't go any further. Other questions? Everybody needs a test like this in your life, okay? Congratulations. You had one. Hopefully you won't get another one. Okay? But you're smart people. You can do well with this. All right, let's talk for a few minutes now about extra credit, okay? So if you'll go to Moodle, this is up in the top section. It's always there, okay? And I'm just going to pull up. This first one gives you the instructions for it, okay? I'm going to make that bigger so I can read it. I've got 4 worksheets practicing just what we did, okay? All right. You can get 1 point for every problem right. I think there's 42 problems. Okay? So some of you that are doing quick math are saying, hallelujah, I can do well here, okay? Good, okay? Now, there are some guidelines to it here, okay? There's 4 of them. These are the due dates for these 4. You can do all of them right now. You have the capabilities. You have the math capabilities of doing them all right now. These are the dates they are due. These are firm. Okay? Don't put it off until October 24th and then come down with the flu and ask for an extension, okay? I'm sorry, life's like that. Okay? All problems must have enough supporting evidence that I can follow your work without having to work the problem myself. I'm not afraid of working the problem. But some of us are accustomed to doing so much in their head that they start with step 6 on the paper. And I have no idea where you got there. So, now you don't have to write down 2 plus 2 equals 4. But give me enough supporting work. If you're having to sit here and think like this, it probably needs to go down on the paper there. All assigned work that is due on or before the due date must be turned in. You can't forget about everything else we're doing in here and just turn these in. So if you have, before this 25th, you've got 3 FRQs, a WebAssign, and 2 homeworks. If all of that's not turned in, I'm not even going to look at your implicit differentiation. It's not eligible to be turned in unless you've done everything else so far. So you've got to be sure that you are keeping up with what's being done there. Not only has it got to be turned in, there has to be a bona fide attempt. Don't do anything smart aleck like turn in the blank piece of paper. Hey, I turned it in. Nope, that's not gonna fly, okay? Give me an effort on the problems that go through, okay? After points are added, no assignment can be graded. So those of you that made an 85, you can't do 43 points worth and get this test up to 128 or something like that. This test is going to stop at 100. Now, if you don't make 100 on the next test, I'll slide them down there and put it on it. Next test, slide them down there and put it on it. So you've got the opportunity to earn all these points back, okay? And then some. Points will be credited to the lowest test grade at the time, okay? So when I look at these, you're going to have just this one test. All those points are going towards that test. When I get to this second one, some of you, this test is still going to be the lowest test grade. I'm still going to go back and add them to that one, okay? I don't want anybody to come in here and say, well, will you add them to this one that's a 96, so it'll look like 100. Mom will be glad I made 100 on the test. Not playing that game. Whatever the lowest test grade is down there, that's what I'm going to add them to. If, by some miracle, you get all your test grades up to 100, then we'll come back, we'll add those on to daily grades that you might need, okay? If by chance you had all of them up to 100, then we're going to add on to FRQs. You ain't going to get all those to 100. Not going to happen. Not enough points in the world to do that. Okay? Now, that's the instruction sheet. These next 4 are the actual worksheets there. There's spots on Shelby. You got those 4 emails and started thinking bad things about me this morning, okay? I forgive you, okay? These things are ready for you to turn in whenever you so desire. Just be sure you get them in by the due date. I've got them on the calendar here. Now, they are not going to show up in RenWeb until I go back and manually put them in for those due dates. So if you always refer to RenWeb, just remember these are not, because if I put them in here so they show in RenWeb, it makes it a grade in the book, and we're not going there with it because it's not going to be an actual grade. So that's what you've got. That's how you can earn some points back on this, okay? When you look at these problems, there are a few on each one that are relatively simple, but they're not all just potato chip problems, people. It doesn't do that. Okay? I mean, there's some that are going to be, really? Whoa. Hold on, I think I got the wrong instructions there, too. I'm going to have to go back. That's not supposed to be the second derivative on all those. It's only supposed to be the second derivative on the last 2. So I'll go back and redo those. Yeah, you don't want to take the second. It's the second derivative just on 13 and 14. But the rest of them, I'll go back, so don't anybody get started. Before lunch today, I'll have that corrected. But some of these are relatively simple. Some of them, when you get down to like something like that, you've got to remember to use the product rule right there, people. Some of you still aren't remembering to use that product rule. You're saying it's y prime and poof, moving forward. It doesn't get you anywhere with it, okay? So be sure that you're using all of your rules there. Did want to clarify on this one here, the second one. Oh, we didn't talk about that problem. We need to on the test. Okay? Y'all remember this problem on the test? Yeah, let's go back and talk about it right quick. There it is. Okay. The table above gives values of the differentiable functions f and g. What does that mean? Derivative exists. Of their derivative at x equals 1. If h is that function, then what's h prime? Okay? Some of you freaked out, started plugging in numbers, and said, okay, well, it's a number, so it must be 0. Okay? H prime. I have 2 things being multiplied together, so how do I take the derivative? Product rule. First, 2 f of x plus 3 times the derivative of the second. What's the derivative of 1 plus g prime? 1 plus g? G prime. Plus the second, 1 plus g, times the derivative of first. What's the derivative of 2 times f of x? 2 times f prime of x. Okay? And now we can plug in. What's f, now we're looking for h prime at 1. So what's f of 1? 3. So I've got 2 times 3 plus 3. What's g prime at 1? 4. 1 plus, what's g of 1? Negative 3. What's f prime at 1? Negative 2. 3 plus 3 is 6. 6 times 2 is 12. 12. Oh, thank you. Yes, thank you. Because I was not getting the right thing there. 2 times 3 is 6 plus 3 is 9 times 4 is 36. Did I do that right? First derivative second plus second derivative first. All right. 1 plus negative 3 is negative 2 times negative 4. That's negative 8. I messed up something here, didn't I? Yeah, it should be plus 8. No, but plus 8 and it's 44. Yeah, plus 8 and it's 44. That's the right answer. So Now, let's go back over here to how we got there. You have, it looks like 5 problems, but it's really 10. Okay? Because this one has 6, so there's a point for part 1, a point for part 2, a point for part 3, part 4, part 5, part 6. Okay? So that's the second one. So don't think, that's 5 problems, I'm not going to worry about that one. That's actually 10 points that you can get on this worksheet. Number 1 is 1, 2 is 1, 3 is 1, 4 is 1, and each of these is 1 point as well. Okay? All right. We will start talking about related rates tomorrow. So all you have that you can be working on tonight is you've got 3 FRQs, which you should be able to do. They're due this Friday, and then we'll start working on related rates tomorrow. The nice thing about related rates is they're word problems. So that means there's not bunches of them. There'll just be a few of them that you're doing. So you'll see a decrease in the number of problems, in the amount of writing you have to do, just an increase in the amount of thinking you have to do in order to solve these related rates problems. You will not have a test over related rates. You have a project due next Wednesday, but after we talk a little bit tomorrow, we can talk about the project, what it is. Y'all will do fine with it, okay? It's a fun activity there. Any questions before the bell rings? All right. Yes, you can work on it. You can't turn it in